What will life on Mars be like? Have you ever wondered where humanity will be living in the next 100 or 200 years? Today, the world's population has exceeded 8 billion, and millions of new people are added to it every year. At the same time, Earth's precious resources, clean drinking water, fertile land, and the dwindling reserves of fossil fuels are slowly slipping out of humanity's hands. Now another dangerous question arises. If someday a massive catastrophe strikes Earth that puts our entire civilization at risk, whether it's catastrophic climate change, the devastating impact of a large near-Earth asteroid, or some extinction-level natural disaster, then where will humanity go? This existential question has forced modern science and space exploration to look toward the heavens. Space agencies like NASA, ESA, and Elon Musk's SpaceX have begun sending their advanced robots, orbiters, and spacecrafts toward various planets in the solar system. And among all these planetary worlds, one planet has received the most scientific attention and funding: Mars. The Red Planet. A world that is extremely cold, barren, and apparently completely hostile to human life. But the amazing thing is that leading scientists, astrobiologists, and planetary researchers believe that in the near future, Mars could become humanity's second permanent home. NASA's cutting-edge rovers, high-resolution orbiters, and international space missions have found compelling evidence on Mars that clearly indicates that billions of years ago, there were flowing rivers, massive lakes, and perhaps a perfect habitable environment for microbial life. But even today, the biggest unanswered question remains the same. If tomorrow humans have to go to Mars and live there permanently, what will happen? Will we be able to get breathable oxygen there? Will we be able to grow sustainable food? Can children be successfully born on Mars? Can humans really leave Earth permanently and survive in an alien world? In today's documentary, in light of real NASA science, peer-reviewed research, and future space exploration plans, we will learn step by step that if humans attempt to establish a colony on Mars, what will their first day be like? What unimaginable challenges will they face? And is Mars really the hope for humanity's long-term survival, or just a beautiful but impossible dream? Be sure to watch till the end, because at the end of the video you'll learn the scientific verdict that might just change your thinking. In the entire solar system, Mars is the only planet that is the relatively most feasible option for human settlement. The Moon is certainly our closest neighbor, but it has no atmosphere, no significant quantity of water ice, and extreme temperature swings. What can we even say about Venus? Its surface temperature reaches up to 465 degrees Celsius, and it has clouds of sulfuric acid. Mars has a day of 24 hours and 37 minutes, just slightly more than Earth. The surface gravity here is 38% of Earth's. Mars' polar ice caps contain frozen water and carbon dioxide. Scientific data also suggests that liquid water may exist in Mars' subsurface. All these factors make Mars a logical and scientifically justified choice for planetary colonization. The story of Mars scientific exploration begins in the 1960s. Mariner 4, 1965. NASA's Mariner 4 spacecraft passed by Mars for the first time and captured the first close-up images. These images revealed that Mars is a barren, crater-covered world, a devastating disappointment for those who hoped for thriving civilizations there. Viking 1 and 2, 1976. NASA's Viking landers landed on the Mars surface for the first time and analyzed soil samples. They measured the detailed composition of Mars' atmosphere and searched for signs of life, but the results remained inconclusive. Spirit and Opportunity, 2004. These twin Mars rovers were designed for 90 Martian days, but Opportunity worked for an extraordinary 14 years. They provided strong evidence that liquid water once existed on Mars. Curiosity rover, 2012. To present NASA's car-sized Curiosity rover is exploring Gale Crater. It has found evidence of ancient organic molecules, methane fluctuations, and habitable lake environments on Mars. Perseverance rover plus Ingenuity helicopter, 2021. This is NASA's most advanced Mars mission. Perseverance is searching for ancient biosignatures in Jezero Crater, collecting rock samples that will be brought back to Earth in future missions. Additionally, the Ingenuity helicopter achieved the historic first feat of powered flight on Mars. Water is the foundation of life, and evidence of it on Mars has made this planet the most exciting topic in planetary science. The Mars Reconnaissance Orbiter has captured detailed images of ancient river valleys, massive lake beds, and flood channels on Mars' surface. The Mars Express spacecraft has detected a large reservoir of liquid water beneath Mars' south pole through radar data. NASA and ESA data clearly shows that billions of years ago Mars had a thick atmosphere like Earth, flowing rivers, and perhaps even a whole ocean. Scientists call it the Paleocean. Today, frozen water ice exists on Mars at the poles, and there is also strong scientific evidence of subsurface briny water. This water can become a source of drinking water, oxygen production, and rocket fuel, meaning hydrogen, for future human missions. Sending humans to Mars requires not just a rocket, but an unprecedented level of scientific planning, engineering innovation, and international cooperation. SpaceX's Starship, the most powerful rocket to date, has been designed for this mission. Elon Musk's vision is that by the 2030s, the first unmanned cargo missions will reach Mars, and then human crew missions will follow. NASA's Moon to Mars roadmap wants to lay the groundwork for Mars missions by gaining experience on the lunar surface through the Artemis program. Preparation for this mission includes developing advanced life support systems, designing habitats to be used on Mars, creating crew health protocols for long-duration space travel, and developing in-situ resource utilization, meaning ISRU, technology so that survival is possible using resources right on Mars. The journey from Earth to Mars is no short trip, it's an extreme endurance test. The distance between Mars and Earth keeps constantly changing, minimum approximately 54.6 million kilometers and maximum up to 401 million kilometers. Using the optimal home and transfer orbit, this journey takes approximately 6 to 9 months. Throughout this entire journey, astronauts face severe challenges like extreme radiation exposure, zero-gravity muscle and bone loss, psychological isolation, and limited medical resources. NASA and private space companies are developing nuclear propulsion and solar electric propulsion technologies that could significantly reduce this travel time in the future. But for now, it's a 7-month one-way ticket, and the return is equally difficult. Landing on Mars is a completely different engineering nightmare. Scientists call it the 7 minutes of terror. Mars' thin atmosphere, which is only 1% of Earth's atmosphere, is not enough for parachute braking, but it's thick enough to damage the spacecraft. NASA's robotic landers have used airbags, sky cranes, and retro rockets. But landing a heavy human spacecraft is exponentially more difficult. Supersonic retropropulsion technology is being developed for SpaceX Starship, where the rocket uses its engines to dramatically slow speed and land safely. Imagine you've stepped on Mars. What will the first day be like? First of all, the pressure suit will be completely sealed. Mars' surface atmospheric pressure is only 0.6% of Earth's, and the average temperature is minus 60 degrees Celsius, but it can go down to minus 125 at the poles, and rise up to plus 20 degrees at the equator during daytime. The landscape you'll see will be dark reddish-orange rocks, vast plains, and distant volcanoes. The sky will be a pinkish-tan color during daytime due to dust particles. Mars' gravity will make you feel surprisingly light. Your weight there will be 38% of Earth's. Walking will feel different. Every movement will require developing a new system of muscle memory. And every 24.6 hours a Martian soul, meaning a Mars day, will be completed. The first experience of going outside will be a profound, humbling, terrifying, and magnificent moment. The first step of humanity's greatest achievement. Short answer, absolutely not. Mars' atmosphere is 95% carbon dioxide, and breathable oxygen is almost zero. But there's some exciting science here. NASA's Perseverance rover is carrying an experiment called MOXIE, Mars Oxygen In Situ Resource Utilization Experiment. MOXIE has successfully produced oxygen from Mars' carbon dioxide atmosphere. In April 2021, it produced oxygen for the first time at a rate of 5 grams per hour, which is enough for an astronaut to breathe for 10 minutes. Future large-scale MOXIE units can create a breathable atmosphere in Mars habitats. Scientists' plan is to create a controlled oxygen-rich environment in greenhouse-like enclosed domes. But on the open Martian surface without a spacesuit, survival will become impossible within seconds. For humans to survive on Mars, three things are absolutely essential: food, water, and radiation-proof shelter. Food production. Traditional farming on Mars is impossible. No breathable air, no protective ozone layer, and Martian soil, regolith, contains toxic chemicals like perchlorates. But NASA-funded research and projects like MELISA, Microecological Life Support System Alternative, show that in enclosed hydroponic and aeroponic systems, meaning soil-free water-based farming, plants can grow in Mars' artificial gravity and controlled light. Potatoes, sweet potatoes, legumes, and leafy greens are top candidates. Water. Mars polar regions have vast water ice deposits. Water can be extracted through subsurface drilling and ice mining. Then this water can be converted into oxygen and hydrogen through electrolysis, which is useful for both breathing and rocket fuel. Shelter. For protection from radiation on Mars, habitats will be underground or beneath thick regolith. NASA and private companies are researching 3D printing technology that can print habitats from Mars' own soil and rocks. Inflatable modular habitat designs are also being developed. Mars' most dangerous enemy isn't its harsh climate, it's radiation. On Earth, our planet's magnetic field and thick atmosphere protect us from harmful solar radiation and galactic cosmic rays. Mars' magnetic field is essentially non-existent, its core cooled down billions of years ago. This means that radiation levels on Mars' surface are approximately 40 to 50 times higher than Earth. According to NASA research, spending 1 year on Mars' surface gives a person radiation exposure that is far more than internationally accepted lifetime safe limits. Cancer risk increases dramatically. Habitats will use radiation-resistant materials, thick regolith covering, and specially designed radiation shelters. Drugs like amifostine and antioxidant-rich diets can also provide partial protection, but this is still an unsolved major problem. Mars' gravity is only 38% of Earth's gravity. This is no simple adjustment for human biology. On the International Space Station, astronauts live in zero gravity, and they have already documented that spending 6 months in space causes bone density to decrease at a rate of 1 to 2% per month. Muscles weaken, the cardiovascular system changes, and even eyesight can be affected by intracranial pressure. On Mars, 38% gravity will provide some improvement compared to 0G, but long-term effects are still largely unknown. Scientists are concerned that Mars-born humans, or those living there for decades, may develop permanently different physiology and become incapable of returning to Earth. Building a sustainable Mars colony, this will be humanity's most ambitious engineering project. Phase 1, Robotic Precursor Missions. Before humans arrive, autonomous robots and AI-controlled machinery will construct a base camp on Mars. Install solar panels, water extraction systems, and 3D print initial habitats. Phase 2, First Human Crew. An initial crew of 4 to 6 astronauts will establish essential infrastructure, sealed biodomes, medical facilities, food production systems, and communication arrays. Phase 3, Growing Colony. With each subsequent mission, the colony will expand. Elon Musk's ambitious vision is that a self-sustaining city of 1 million people is possible on Mars, but most scientists give a timeline of decades or even centuries for this. Every colony module will need redundant life support, emergency backup systems, and psychological support infrastructure. For Mars population to grow, a revolutionary and ethically complex question: can children be born there? Currently, successful reproduction in any mammal in space or low gravity is scientifically unproven. Animal studies show that embryonic development can be severely affected in microgravity. Radiation exposure can cause DNA damage, which dramatically increases the risk of miscarriages, genetic mutations, or birth defects. How Mars low gravity will affect pregnancy, placental development, fetal bone formation, cardiovascular health, all of this is still highly uncertain. Mars-born children, if successfully born, growing up in Mars' lower gravity could be physically different from Earth. Their bones could be longer and thinner, muscles weaker than Earth humans, and they may never be physically capable of returning to Earth. This would lead to a Mars society that is truly and permanently different, an alien world's own native inhabitants, the boldest and most ambitious idea, transforming the entire Mars planet to be like Earth. This is called terraforming. The theoretical terraforming process includes these steps. First, greenhouse gases would be released on Mars, such as carbon dioxide, methane, and water vapor, which would thicken Mars' thin atmosphere and warm the planet. For this, ammonia-rich asteroids could be deliberately crashed on Mars, or factories on Mars' surface could produce industrial greenhouse gases. Elon Musk himself proposed the controversial idea of nuking Mars poles so that frozen carbon dioxide would be rapidly released. If the temperature increases by 4 to 5 degrees Celsius, Mars' permafrost would start melting, and a chain reaction of carbon dioxide and water vapor could begin. But developing a breathable oxygen atmosphere, according to most optimistic scientific estimates, would still take thousands of years. Restoring a stable planetary magnetic field is still scientifically beyond our current capabilities. So in the end, can Mars really become humanity's second home? Both scientific evidence and technological progress together are saying, yes, but it won't be easy. The challenges are unprecedented. Radiation exposure is life-threatening. Oxygen for breathing will have to be artificially produced. Food will have to be grown entirely in controlled environments. There are massive unknowns about human reproduction and child development. The journey itself is 7 months. And communication, sending a message on Mars can take 3 to 22 minutes depending on planetary positions, so there will be no real-time help. But this is the true identity of humanity. We have never been defeated by impossible challenges. We have crossed oceans. We have survived the extreme harshness of the North and South Poles. We stepped on the moon in 1969 with technology that was less powerful than today's smartphones. And today NASA, SpaceX, China's CNSA, and the European Space Agency are all actively preparing for human missions to Mars. By the 2030s or 2040s, the first humans could land on Mars. By the 22nd century, if humanity remains focused in this direction, there could be permanent settlements there. And millennia later, perhaps Mars will be a different world, green and full of life. Mars is humanity's hope, and that's what science is saying. But with this comes a profound ethical responsibility. Do we have the right to permanently change an alien world? Is there any microbial life there that we haven't even discovered? Are we ready to become a multi-planetary species? The coming generations will answer these questions. But today, the combination of science, technology, and human ambition is saying, Mars is not far. Mars is possible. And Mars is humanity's next chapter. If you found this documentary script informative, please like this video, subscribe to the channel, and definitely press the bell icon so that every upcoming space exploration documentary reaches you first. Definitely tell us in the comments, would you like to live on Mars? And on which space science topic would you like to see the next documentary?